9540, you have 9540 certified, so it's already to go. And this has been listed in CEC, and we also work in HECO. So it's all ready to go. This is my last slide. Just want to bring this up a little bit.
Yeah.
Talking about why CNI ESS, and I know we talked about that, just a couple of months ago already. But this is a visual. It's a kind of typical low curve for a CNI building.
Mm-hmm.
Where in the afternoon, once the AC kicks in, right, you have the power going up and then going down in the evening when people get off work.
Yeah. It's like a typical office building or something like that. Yeah.
You get a typical office building or school. So typically the utility charge you for energy as well as the demand charge.
Yeah.
If you have high peak, then demand charge can be pretty high.
Right.
Even 50%, 70% of the bill sometimes.
Yeah.
So with solar, you can kind of oversize the solar, and then once the solar kicks in the day, the energy kind of go down, the total power kind of go down, right? Because of the solar. And you kind of also, if you size the system up, big enough, then you probably can sell some of the solar energy back to the utility.
Yeah. In the NEM 1 and NEM 2 era, you would probably oversize that so that green area under the line would be even bigger. But now with NEM 3, because there's not as much value to that overproduction, because utility is not buying it at retail rates anymore, you probably size it more like this today. That makes sense. Yeah.
Well, with storage, you can still size it up, right? You can.
Yeah. You can still arbitrage that. Yeah, exactly. But even if you sized it like this, what I guess your point is that demand charge is lower, but it's maybe 10% lower than what it was before because.
Well, the demand charge is maybe still there because the peak is not eliminated, and the solar goes down. It's not detachable, right? Depends on the sun. So if you got a cloudy day, then you still get a demand charge. And again, like you said, like you may be wasting the power sending to the grid because it's so cheap. And even in summer, right, in August in California, you're talking about maybe very, very cheap power selling if you're, sending power back to the grid.
Yeah.
With the storage, you can kind of reshape the whole curve, right? You can store the excess power from the PV to the storage and discharge the storage later when the peak is still high. So you can kind of eliminate the peak demand in your utility bill, and that saves you a lot.
So your peak demand is never higher than what it was in the early hours of your morning time.
Right, you can manage to do that if you have your inverter. If you size your solar and the energy storage properly, you can manage to do it. Yeah.
I'm assuming there's a whole ecosystem of consultants and designers and engineers that are designing these solutions because it's getting more and more complicated. It's not as simple as just using the good old helioscope and aurora anymore. Now there's like a couple of layers more of sophistication, which Energy Toolbase and other products like that probably help model in the sales process of these projects. And
exactly.
Yeah.
And different, I guess, different places, they have different time of use program, and again,
different rates, different rules, different demand charges, different mixes of cost. Yeah. So very optimized. It's like in the early part of the 20th century, there used to be a title called VP of Energy in corporations, Vice President of Energy. It seems like we need that again because this is not so straightforward. Yeah.
Because right now, I guess, it's more complicated because of different buildings also have different load profile. So you want to optimize the installation based on that profile as well, right? So this is a typical one where you have power in the day, but some of the building, like some manufacturing site, you may have power consumption at night as well, right? So it's all different, and also some agriculture side.